So good evening, Triveni. Just confirm whether I'm audible and visible.
Good evening, sir.
Yeah. So you can share your screen, and I'll ask you to write few programs and functions. Once you try that, and after that I'll explain you a concept called recursive functions, and that will be end of functions topic. So you can share your screen. We can start writing a program. So the program is you need to read two numbers. You need to read two numbers, and you should find the biggest of two numbers using functions concept. So you declare one function also. You declare one function. Uh, you can keep any name for your function. You can keep any name like big two, max, maximum, whatever the name you like. You can give. Okay, and very good. And what it will return? It will return one integer. So before that max function, you have to write the return type. So that is correct actually. A comma B is correct actually. Yeah. This is known as function declaration. So for your convenience, if you want to write, you can write one comment also there for line number 4. Like this is a function declaration. Fine. Now you read value into these two variables A and B. After that, you can print like the biggest number is, and you can keep percentage d there. Okay, and you have to call a function, and in which you have to pass two variables a comma b. So whatever the biggest number is there, that will be returned and that will be printed on the screen. And this is known as function call or function execution actually. If you want to write it in comments, you can write it function call or function execution. Function execution. Now what you have to do is you have to define the function. So this is known as function definition actually. This is known as function definition. Integer will be the return type. Max will be the function name. And the A and B values you have to receive in some two formal parameters. You can take X and Y, it's okay, no problem. And here you can say, if X is greater than Y, then you return X. Otherwise, you return Y. That's it. This is known as function definition actually. Line number 15, you can put a comment if you want to write. Integer max, spelling wrong. Yeah. Semicolon for x and y. Written x and y. Fine. So like this, you try one more example. That is, write a program to read a number. Write a program to read a number and print number of digits from that number using functions. Yes, return type is integer. Digits is the function name. Okay, very good. Fine. You need not to take a variable like remainder equal to 0. You can take digits like d equal to 0. Integer d equal to 0. Okay, and you can say while the x is not equal to 0, while the x value is not equal to 0, you have to keep on dividing that x by 10. X equals to x divided by 10. Every time whenever the x is divisible perfectly by 10, you have to keep on incrementing the divider d value. And after coming out of the while loop, you have to return the d. Okay, so number of digits are 1, 2, 3, 4, 3, 5. Fine. So now you got clarity about functions concept. Functions is all about instead of writing the logic of the program within the program, you are separating it from the main program so that this particular logic can be used any number of times, anywhere, wherever it is required. That's what the main objective of functions is. So once if you got clarity on this, then we can move to the next topic. And if you ask me, like how many programs we can practice, then till now, what are all the programs you have learned in C language, that everything you can convert into functions. There is no limit on that actually. So it's all about like how much you practice. Uh, that makes the difference. And for your practice, I have included uh, like few programming examples in our learning management system that you have to practice it. Anything else, Triveni, up to this? Any doubts?
No, sir, clear.
Clear? Okay. Then you can stop sharing the screen. I'll explain you the next topic. That is recursion, or you can say recursive functions. So what we have seen is right now we have seen that like you have done some two programs by your own, and from that you might have understood that while working with functions, you have calling function as well as the called function. So let's try to understand what is actually calling function and what is actually called function. Once that is clear, then I'll explain you one example related to pointers. So, so actually what you have done is you have written main. Inside main, you are calling one function, say f1. And here you are defining f1 function. So main is known as calling function. Okay, whereas f1 is known as called function. It is known as called function. So whenever the main function calls this f1, control goes to f1, it executes all the statement, and the control returns back to it. But when this f1 function is called by f1 again, then it is known as actually recursion. Means the, the definition of recursive functions is when a function calls itself repeatedly till a condition is satisfied, then we can call it as a recursion. So let's try to understand practically how the recursion works. So I'll open at 8 to 9 p.m. Here, I'll declare one variable called integer x, whose value I have set to 1. Then I'll say display, and I'll pass the x value to the display function. Okay. And here, I'll define one function called display, and that x value, I'll receive it in same x variable. So you can have actual parameter and forward parameters as same actually. And here I say if the x value is greater than 100, then I'll say return. Else what I'll do is if it is not greater than 100, then I'll say print of percentage d comma, I'll say x, and then I call the display function. I'll call the display function and I'll pass x after incrementing it. So I'll say, I want to first increment the x value. So I'll say plus of x actually, and then I'll call the display function. Now you just see the output of the program, then you'll understand. Let me put here /t. So here you'll get like 1 to 100 natural numbers on the screen. You can observe, but you can see there is no while loop, there is no do while loop, and there is no for loop. We are just working with functions only. So here actually main is known as calling function, and display is known as called function, And this display is calling the display again. So it is known as actually recursion. So while working with data structures, actually, recursive functions makes your program quite simpler and easier. So if I if you want to know the real life example where actually you can make use of recursive functions, then suppose if I ask you to convert a decimal number to binary, a decimal number to a binary number. So generally you think that like you have to keep on dividing a number and you have to print the remainder. So if you take the number 10, if you divide it by 2, 5 times it will go and 0 you'll get it. So if you print 0, then this will be the output. Then 2 times it will go and 1 will be the remainder, then you'll get 1 actually. Again, 2 ones 2, 0 is the remainder. Is it clear? So you'll get 0 and you'll get 1. But actually, the decimal equivalent of for 10, the binary equivalent is, it's not actually 0101, it's actually 1010. So here what happened, you need to call this expression, but you should not evaluate it actually. So recursive functions will make a call to this, will make a call to this, will make a call to this, and after that the execution will start so that you'll get output in this way actually. Otherwise, what happens, you have to collect this result inside one array and you have to again reverse that array, then only you'll get the exact result. If you want to try, you can try it converting a decimal number into a binary normally. So I'm not saying that it is not possible. Definitely it is possible. But immediately after performing the division, you should not display the result on the screen. You have to collect that reminders inside an array and you have to reverse that array, then only you'll get the correct answer. But the same concept can be implemented easily by using recursive functions. So what you can do is you can first try this example, converting an decimal to binary normally without using any recursion concept. After that, you just look for an example that how we can solve this problem using recursion. Then automatically you'll find the difference actually. Now, while working with functions, uh, sometimes you'll come to a situation where you won't be able to change the values of the variables in the main program. So for that, you have to work at the address levels. And that's where the concept of pointers will come into picture. Now, here I'll declare a variable 10 number whose value is 10. Okay, and I'll declare one pointer variable ptr and I'll assign the address of this number variable to this ptr. So ampersand indicates address of operator. Now here I'll say print of /n number is percentage d comma, I'll print the number variable's value. Here I want to print the address of the number variable. So I'll say address of number is, and see whenever you are printing address, don't use percentage d, use percentage u, because percentage u stands for unsigned integer. That's the thing, but addresses will not have any signs actually, positive or negative. And you can say ampersand of number. And in the same way, you can say /n value of ptr. And what ptr holds? ptr holds address of number. So address ampersand of number and ptr will give you the same value. Okay, now we can say /n value at ptr is you can say percentage D and like star PTR. Star PTR will give you value which is stored at the address location of PTR. Value which is stored at the address location of PTR. Okay, now let me check where the problem is. Integer, okay, sorry. Uh, if it is a pointer variable, I need to declare it as a special variable. So I need to use star symbol before this PTR. Now you can see the address of number variable is 64222036. The same thing you have assigned to pointer variable PTR. So that also will give you the same number. And if you can see, the value which is stored at the PTR is 10 actually. So this is what the basic uh, concept of pointers is. Now we'll try to do one program that you do it. You just try to do it. The program is read two numbers A and B and swap it using functions. And whenever the swapping will not happen, I'll help you how you can do that swapping by using pointers concept. So you can share your screen and try writing a program that how to swap values of two variables A and B using functions concept. You can try this. Yeah. So you just run this program and you'll see that the values are not getting changed. Now what you can do is you can create another copy of this program, and now we'll try to implement using pointers concept, this one. So you put like if you want to do modification here itself, then you can do it. You can put star symbol, integer star, no after the data type actually, right? Integer star, yeah, integer star. This indicates that swap function is going to read the address of a variable in a pointer variable, okay? And for the swap function, you pass addresses. So ampersand of A comma ampersand of B actually. So you're not passing actual parameters, you are passing the addresses of actual parameters. So this particular call becomes a call by reference. Earlier it is called by value, now it is called by reference. And what are the values you are receiving that should be received inside a pointer variable. So x should be of pointer type and y should be of pointer type. So star x and star y. Now here temp equals to star x. No, that is not a pointer variable. Temp, it is an ordinary only. Yeah, star x equals to star y and star y equals to temp. Okay, so now you can just run and check it out, check this program. You can observe the values are getting changed. And this is we call actually call by reference. Now you try one more example, that is you read array of 10 integers and you display it using pointers concept. So you declare one array of size 10, okay, and you declare one function also with the name display, whose return type will be void actually, because it won't return any value to the main program. It will be void, and we can say function name is display, and it is going to read the address, the first byte address of the array. So you can say it's an integer pointer. It is going to read integer star, no space, integer star you have to give. The integer pointer that indicates actually. Now you read value into this array using for loop. 10 numbers you read it. See, this integer I equal to 0, you need not to declare it. What you can do is, you can remove line number 6, and at line number 4, comma, and you can just declare a variable I there itself. And no need to initialize, because initialization is done at the loop level. Yeah, I is less than 10 and I plus plus. No, it's ampersand of ARR of I. Yeah, fine. After reading these 10 numbers, what you have to do is you have to call the display function, and you have to pass the address of this ARR array. So line number 12, we can write the display function. Display, no printing. You will call the display function. Display ampersand of ARR. Ampersand of ARR. That's it. Now you define the function. Now we'll define the function. Integer star x you can take. Any variable, it's okay, no problem. So what happens, like the first byte address you will be receiving in x variable. Now you can start one for loop, and you can start displaying the array elements. I is 0, I is less than 10, I plus plus. And you have to say printf /n percentage u hyphen percentage d. Print the address as well as data both. So address is available in x actually. So you can say x. Value is available in pointer x. So star x you have to say. And every time you have to increment that address to next 4 bytes. So after this printf statement, you have to say x plus plus. Then only the x pointer variable will be updated to the next 4 bytes address. So you can try this. So here the problem is there is no I in this function actually, because you have declared I within the main. So don't declare it here, because see, suppose in future if you are writing like 10 functions, so it is not recommended to declare the same variable 10 times in 10 different functions. It's better you declare globally before the main. So you remove that I variable here inside the main function, and that I variable, because it is required in the main function as well as in the display function. So you remove it here and you declare it above the main. And that concept we call it as a global declarations. No, not here. Yeah, to press enter key after line number 1 actually. Yeah, now you declare it here, integer I. And for your convenience, you can write a global declaration as a comment. Okay, now you can run this program and you can see. So you can see the memory addresses exactly 444 differences will be maintained, because as we have learned that in array all the data will be stored in the consecutive memory locations. For every 4 bytes there will be one integer data. So 536 after 540, 44, 48. So 44445 difference will be there. So what you can do is, if you like declare it as a uh, like long short array, like you have declared this array as an integer type, which is going to occupy like 4 bytes. What you can do is, you can say short int. The array name you can write it as a short int actually. You can go up and you can line number 6. You can say short int. Okay, and here the display function is also going to read address of short int only. So line number 7 you have to change it again short int. It's not integer pointer, it's a short integer pointer. Here line number 16 also you have to change it, because it is a short integer pointer. Now you just try to run this program and see what happens. So you can observe only 2 bytes difference is maintained in between these numbers, because one short integer occupies only 2 bytes of space in the memory. You can run it once again and check it out. So here you can see 52, 54, 56, 58, 2 bytes difference is maintained. Is it clear? So this is how you can deal with like memory addresses. And you have to understand that even if you are not working with pointers, but internally all the array operations are performed by C language using those memory addresses only. Like this, you can try different examples. You can try different examples like read a string and you display it character by character. And when you display it along with the memory addresses, you'll see 111 byte difference, because character occupies only 1 byte of space in the main memory. Like this, there are like n number of programming examples that you can try uh, to to increase your practice levels. Okay. So any doubts you have in pointers, Trivedi, just let me know. Or is this clear?
Yes, sir.
Clear, no doubts. So when you will start working with those uh, self-learning video modules, have you started that or not yet started?
No, sir, not yet.
When you will start? I think you said today or tomorrow. I think
Yeah, sir, today, sir.
today you will start.
Yeah, sir.
So you have to complete that flowcharts and pseudocodes. It is a 6 hours course. Daily, if you spend 1 hour, then it will take 6 days of time, and you'll understand what software industry is all about, how applications are built. And remember, we are writing programs directly by opening the IDE and we are implementing it. The reason is we are simply solving the very simple problems, or the problems which are already solved by someone in the industry, and we are aware of that logic. That's why I'm explaining you that so easily. But when you come across a new programming model, a new logic, then without doing rough work, it will be very difficult for you to solve that problem. And doing that rough work, making that preparation is all about flow charts and pseudocodes actually. So that is one foundation level program that you need to understand. So finish it as immediately as possible so that you can begin with C programming language self-learning modules also. So if you have any doubts, you can let me know.
Sir, it
Yeah,
shows us.
it's showing mystr.h. So you open mystr.h once and show me what you have written inside that. You can type the file name there, mystr.h. So that header file is not there actually here. And remember, if it is there in another folder, then your program will not work. Why? Because when you put the header file in double quotes, it, it is going to search for that particular supporting header file within the same folder where your main program is running actually. So if you think that you have done that header file mystr.h, then you have to check whether it is available within the same folder or not. Otherwise, you can define that now itself.
Okay, sir.
A C program training is the folder. Inside that, this header file should be there actually, but it is not there. Am I right?
Yeah, sir. Maybe I saved in another folders.
Folder. Okay. So what you can do is you can search and that header file you put it in the same directory. Then this program will work comfortably without any problem. Is this okay till now?
Yeah, sir. Okay, sir.
So what you can do is you can just open that learning management system what I have given to you. At least you can open that, and I'll show you few programming examples also. If you can log in into your portal, courses.atishjain.in is the courses dot, yeah. So you log in into this. Now you can go to this um, C programming language classes. You will find everything whatever I'm teaching here live in the class in a more detailed way, because if it is a live class, I can take the session for 1 hour actually. But they are like professionally recorded videos. For each topic, you'll find only one video actually. You can still go down and you can try this excel your coding skills with C language hands-on lab. You can just click on that. So what you can do is, uh, if you have practiced this, have you done this once? If you are getting revisit means I think you have done this. Am I right?
Yeah, sir. I done this.
You have done all these programs. Very good. Have you just gone through the videos or you have practiced also?
No, sir. Just I saw the program and write the codes.
Okay, you have written the code. So
Yeah,
what
sir.
I want is, this is just, this module is only for the basic level programming. Okay. So just you can go up again. You can see only for decision making, I've given 19 lessons in hands-on lab. All these 19 are 19 different programming examples actually. Okay. You can still go up. Loops, you'll see 24 different programming examples. Each program will be at different level exactly. You can just go up. Okay, now arrays, what we have done now, like this in arrays, there are 25 programming examples are there. You can still go down. Strings, 21 are there. Next, functions, 22. You can try this. And pointers, only few concepts are there, because the actual logic in C language you learn up to functions, and after that actually there will be some concepts only, like pointers, structures, files. Those are actually some concepts which doesn't have much logic, but you need to understand that why you need to work with structures, why you need to work with files, why you need to work with command and arguments, and all those stuff we'll see actually. So what I want is, I want you to practice all these programming examples. Okay, and whenever if you have any doubt in these examples, I'll be there to help you, to clarify you in a more detailed way actually. So Triveni, do you feel that if you do these many programs, then definitely your confidence level will get to next level?
Yeah, sir.
Hmm? So keep doing, and even after the end of this program also, uh, we'll have every Friday review session. Actually, we call it as a weekly mastermind, where I'll ask all the students that what is their schedule in the whole week and what they have done, and if they have any doubts, actually, I help them to clarify. So you can attend that particular weekly mastermind for next 1 year also, and then based upon your convenience timing, you can complete all these modules slowly. Okay.
Okay, sir.
So thank you so much, and see you tomorrow with one more new topic, that is structures in C programming language. Okay. Bye.